Alright, welcome back. Math 1720, Chapter 5, Section 1. We're going to get into fundamental identities. A lot of these basic identities we've already kind of seen before and used a little bit, and we did it in Chapter 2 with using degrees and things like that. Okay, so a lot of this is just going to be making sure that you have a trig identity sheet that you create. So when you're doing your assignments, you have this as a reference guide. So make sure you pause the video or take the time to write all these out and have all the identities and name them. So like for the reciprocal identities, I'm going to kind of fly through some of the identities that we've already used. We know the reciprocal ones, right? Cotangent of theta is 1 over tangent. Secant of theta is 1 over cosine of theta. Cosecant is 1 over sine of theta. All right. The quotient identities, right? We just got done using this one, graphing sine and cosine, when we needed to graph tangent, right? So we know that tangent is the ratio of sine over cosine, right? Because remember that that's opposite over adjacent, or your vertical over your horizontal, all right? And then we know cotangent is literally tangent flipped, so it's cosine of theta over sine of theta. And then we hit, briefly we touched on the Pythagorean identities. All right, sine squared theta plus cosine squared theta equals 1. And we got tangent squared of theta plus 1 equals secant squared. So know that tangent squared and secant squared are married. And then cotangent squared plus 1 equals cosecant squared. So know the cos there are married. Cotangent squared and cosecant squared are married there for your Pythagorean identities. Okay? Now, even and odd. All right, we talked about this when we talked about graphing last chapter, when we talked about sine and cosine being even and odd, where sine was odd and cosine was even. Remember, for something to be even, we are able to fold it across the y-axis and it would sit on top of itself. If it was odd, you would fold it across the y-axis and the x-axis, all right, and it would be on top of itself. So we can see that the base or the parent function of sine, if sine of negative theta, all right, if that's negative theta, then cosecant of negative theta will carry the same value. So sine of negative theta equals negative sine of theta. Therefore, its reciprocal, cosecant of negative theta, will be negative cosecant of theta. Okay, so in this case, whatever the parent does, the reciprocal identity does the same thing. So since cosine's even, cosine of negative theta equals cosine of theta. All right, and we've talked about this before. We talked about this in chapter 4. Therefore, secant of negative theta equals secant of theta. So make sure you guys got all this written down. You can obviously see the tangent one there as well. So just remember, the only one that produces a positive output is cosine and secant. The others output negatives, okay? So just remember that. All right, let's use this. Let's apply this. So we're going to choose the identity. So this is where it's important that you have your identity sheet next to you as we solve these problems. So you can see, hey, based on what's given, which identity should I choose from to solve? All right, so a couple important things in this example. All right, it says if tangent of theta is equal to negative 5/3 and theta is in the second quadrant, find each function value. We're going to do a few examples. They're going to carry on to the next slide. But the base function value is tangent of theta is negative 5/3. Second quadrant is important, okay? That tells us if the negative goes with the 5 or if the negative goes with the 3. So you should know, right, tangent is opposite over adjacent. All right, the negative would go with the 3. You could draw your triangle out in the second quadrant, use the reference angle, and solve for secant of theta. Okay, we can also use, and that's what we kind of want to focus on in this chapter, is an identity. So if you look at your sheet, think about which identity relates tangent and secant. All right, it should be your tangent squared theta plus 1 equals secant squared theta. So we're going to substitute stuff in there. All right, so that's our Pythagorean identity. We're going to substitute in what we know. We know that tangent of theta is negative 5/3. So we're going to substitute that in for tangent. So we're going to get negative 5/3 squared plus 1 is equal to secant squared theta. So we're going to square that, right? So we're going to get negative 5 squared, right, is 25 over 3 squared, which is 9. So you're going to have 25 ninths, okay? Now, when you get 25/9, you have to change the plus 1 to 9 over 9. So you're going to get 25/9 plus 9 over 9. So you're going to get 34 over 9. That's where that comes from. Equals secant squared. Now, secant is squared. How do we undo a square, right? We should square root both sides. Remember, when we're solving and we square root both sides, there's two answers. There's a plus and a minus. Okay? So when we do that, we get plus or minus. And in quadrant 2, though, how do we know if we choose the plus or minus? Because in quadrant 2, what's positive? Remember, all students take calculus. So in quadrant 2, sine and cosecant are positive. So we have to choose the negative answer because we're looking for secant. All right, so secant of theta is negative square root of 34 over 9. We can rewrite that as negative square root of 34 divided by square root of 9. So we can break up the radical. All right, and the square root of 9 is 3. So our final solution for this one is negative square root of 34. All right, for the next part of the example, we're still using tangent of theta equals negative 5/3, and we're going to use the secant of theta as well. That'll be in part C, but for this one, all right, we have sine of theta, and we want to solve for sine of theta, given that we know tangent of theta is, I'm going to flip back the screen, right, negative 5/3, and we're in quadrant 2. So, once again, have your identity sheet out next to you, and we can clearly see that tangent of theta is sine of theta over cosine of theta. All right. Well, why would I choose this one? Well, what did we solve for in part A's example? We solved for secant of theta, and we know that secant is the inverse identity of cosine of theta. So we know what tangent of theta is, all right? That was given to us originally. We just found what secant of theta is. We can use secant to find cosine, and then knowing tangent and cosine, we can know sine. All right, so that's where that's going to stem from. So we know that if we just solve this algebraically first, we know that sine of theta is going to equal cosine of theta times tangent of theta when we do this. Now we're going to replace cosine of theta with 1 over secant of theta because we know what the value is. We just calculated in part A of this example. So we have 1 over secant theta times tangent of theta is equal to sine of theta. So now we're going to put those in with our values. So 1 divided by the negative square root of 34 over 3 times negative 5/3, that equals sine of theta. So remember, you're going to multiply the numerator and the denominator by the reciprocal of negative square root of 34 over 3, which is 3 over square root of 34. All right, the 3's will cancel. You're left with 5 divided by the square root of 34. You have to rationalize the denominator, so we're going to multiply by square root of 34 over square root of 34. All right, so we end up getting 5 square root of 34 divided by 34 is our sine of theta. How about if we do cotangent of negative theta? All right, so remember, this is going to be what? An odd function, so we know that we have to end up with a negative answer here. Or the opposite, sorry, not necessarily meaning it's negative, because if we're starting with a negative, it means that we'll end up with a positive in this case. All right, so we should recognize that. And then we know the reciprocal identity. The reciprocal identity for cotangent is 1 over tangent, and we were given what tangent was, okay? Now, we have to apply the negative angle identity, so that's the first part I started this example off with. And we're still using the same tangent of, was it negative 5/3 that we started with in the first a couple slides ago, okay? So, cotangent of negative theta, we solved that and used the negative angle identity, is equal to 1 over, right? We got to change the sign in front of tangent to negative. All right, so it'll be negative tangent of theta. Then we substitute in our given values. So 1 divided by negative 5/3 ends up giving us positive. Negative times the negative is a positive. Then we got to multiply the numerator and the denominator by the reciprocal of 5/3, which is 3/5. So when we do that, we end up with cotangent of negative theta is equal to 3/5. All right, so there's kind of working through all the different aspects on those. All right, just make sure, all right, this is a big issue that people have. When we take the square root of a number and we're solving for a variable, remember there's a plus or a minus sign. and you have to make sure that you pay attention and choose the correct quadrant. All right, so if it's asking you for, quadrant 2, like in the example, we know that only sine and cosecant will be positive. If it's asking for quadrant 3, only tangent and cotangent will be positive. If it's asking for quadrant 4, only cosine and secant will be positive. So you got to remember that all students take calculus that applies to quadrants 1, 2, 3, and 4. All right. So this is where it gets a little bit more challenging, is rewriting all the trig functions in terms of each other. So example 2, we're going to write cosine of x in terms of tangent of x. So have your trig identities out, and we got to find the right identity that's going to help us do this. So we got to rewrite cosine first, okay, and then we want it to end up in terms of tangent of x. So always try to evaluate and find something that's easily relatable. Okay, we know that secant relates to cosine because it's the inverse identity. Okay, so we know that secant and tangent are related by a Pythagorean identity of tangent squared plus 1 is equal to secant squared. So now I can replace secant squared with my cosine function now. So I'm going to use the reciprocal identity. So what I do to one side, I do to the other. The reason we're rewriting both of these as 1 over each is because 1 over secant squared is equal to cosine squared. You don't have to do 1 over right away, but eventually you will have to, because when you rewrite secant squared, it becomes 1 over cosine squared. So the only reason that we're taking the reciprocal identities of both sides, it's not or just taking the reciprocal, remember what you do to one side you can do to the other, is simply for saving some algebra steps. Okay? Because now I can rewrite 1 over secant squared x as cosine squared x using the reciprocal identity. Now I have to solve, I have a cosine squared x, so I have to just get cosine of x, so I got to square root both sides. When I do that, I get plus or minus the square root of 1 over 1 plus tangent squared x. Alright, and then I can rewrite that as the square root of 1 over the square root of 1 plus tangent squared x. And then I have to rationalize the denominator. But you may or may not want to do that, because 1 plus tangent squared is also, equal to something. So careful when we do quick, cancellations and things like that. But in this case, we do want to rationalize, okay? I just cautioned before because sometimes you're going to want to replace that whole function with something else. But in this case, we do want to rationalize. So when we do that, we got to multiply the numerator and the denominator by the square root of 1 plus tangent squared x. All right. So when we do that, on top we're left with plus or minus the square root of 1 plus tangent squared x divided by 1 plus tangent squared of x. Okay. Now the sign depends on the quadrant that we end up in. So just remember, this is no different than we rationalize a number. Say we had 1 over the square root of 3, right? You would multiply 1 over the square root of 3 times square root of 3 over square root of 3 and get square root of 3 over 3. Same exact concept here. We just have a trig function, and you can treat that whole thing as one variable when you do that. All right, let's do one more example here. We're going to rewrite 1 plus cotangent squared theta divided by 1 minus cosecant squared theta. We're going to rewrite those in terms of sine and cosine, and then we're going to take it to the next level and write it so that there are no quotients. So that means we're not going to have any denominators. Alright, so first bet here is to rewrite both of those. So write cotangent squared as cosine squared theta divided by sine squared theta, and rewrite cosecant squared theta as 1 over sine squared theta. Now we have to do a little algebra trick of how we clear the denominators. I can multiply the numerator and the denominator by sine squared. Okay, I'm just multiplying by 1. Why am I choosing sine squared? Because it's the denominator and it's what I want to cancel. So I'm going to multiply the numerator by sine squared and the denominator by sine squared because they have the same denominator of sine squared. Alright, so when I do that, okay, I'm going to distribute sine squared to both terms. So on top, I'm going to multiply 1 times sine squared and I'm going to multiply cosine squared. over sine squared times sine squared. All right, the sine squareds will cancel there. And same thing on the bottom, you do the distributive property. So when you do the distributive property, in the numerator, we end up with sine squared theta plus cosine squared theta. In the denominator, we end up with sine squared theta minus 1. Now, take a quick glance at your Pythagorean identity. There's a really important one there, fundamental one, right? Sine squared theta plus cosine squared theta is equal to what? 1. Okay, so you can replace the numerator with a 1. Also, if you use the Pythagorean identity, sine squared theta plus cosine squared theta is equal to 1, and you solve it for cosine squared theta, all right, that'll help you eliminate the denominator. If you solve the Pythagorean identity for cosine squared theta, you end up with 1 minus sine squared theta, and then you can just change the sign on it and get negative 1, okay, minus the sine squared theta, or plus the sine squared theta. So you can rewrite all of those. So the top goes to 1, and the bottom, you use the Pythagorean identity of sine squared plus cosine squared theta is equal to 1. You solve that identity strictly for cosine squared theta, and then you replace it in the denominator. So you can rewrite sine squared theta minus 1 and replace it all with negative cosine squared theta. So really only one more step. Remember, this problem said to solve it so that there are no quotients, okay? So we have to use the reciprocal identity. We know that 1 over cosine is equal to secant, so this ends up being negative secant squared theta is our final answer, okay? All right, so just make sure we always write the argument of the function. Don't get lazy and just write sine, tangent, cosine. Always write sine of theta, cosine of theta, okay, and those sort of things, or it will start screwing you up when you actually do these. Okay, don't write this as sine squared plus cosine squared equals 1. It needs to be sine squared of theta plus cosine squared of theta equal 1, or sine squared x plus cosine squared x equal to 1. Alright, so very, very important that we pay attention when we're doing that. Don't come up with some sort of shorthand. Alright, as usual, email me if you got questions. Else, go over in class. We'll probably run through a few extra examples on this one for you guys. But, you know, practice being able to rewrite those. And like I said, most important thing, create yourself a trig identity sheet. So when you're sitting there doing your assignment, you can look back and forth and see, hey, what replaces what the best. Okay? Alright guys, we'll see you in class.